Hello friends, welcome. Friends, this is the module 2 of the series which I have started recording on the topic called satellite technologies. Today, in this module, we are going to touch upon satellite spectrum bands. The topics which we are going to cover in this module is how satellite spectrum strategies differ from terrestrial network, why satellites need large spectrum blocks, what are the frequencies bands which are typically used by satellite and for what purpose, why for broadband we need higher frequency blocks, spectrum sharing between satellite operators, beamforming and frequency reuse, challenges of high frequency band, why some services still need low frequency band, and convergence with satellite versus cellular spectrum. Right? Some of these topics can be covered in detail in future videos. Now, satellite versus terrestrial network. This is pretty important, friends. The terrestrial network and satellite networks are fundamentally different, and today we are going to talk about the reason why. Typically, you see an urban area, these are buildings. Now, in order to cover this urban area using a mobile coverage, what you typically do? You have large number of towers deployed in this area which is capable of serving the population. Why large number of towers? Why not one tower? Because the quantum of spectrum is quite limited, because these cell towers operate at low frequency band, not at high frequency band. Because the quantum of spectrum is limited, you need so many towers to repeat the spectrum, which is called frequency reuse, so that each and every geography is able to use the full block of spectrum. So if you have n number of base stations, then the frequency gets multiplied by n, so that capacity can be enhanced by putting more number of base stations. Simple, right? Now, in case of satellite, there is a challenge. There are two types of challenge. The first challenge is that you can't use so many base stations in the sky, because the satellite can be considered as a base station in the sky compared to what you can do in case of terrestrial network. The other challenge is the satellite is located at a height. This height can vary, but it is always in kilometers. Kilometers means hundreds of kilometers. Now, this is, if it is Starlink satellite, this can be 550. If it's a geostationary satellite, it is 36,000 kilometers. Because the distance is very high, then what happens is that the coverage area that you have, the footprint of these satellites become pretty large. Because when you are transmitting RF beams from such a great height, how much sharp that the beam is, still the coverage will be very, very large. Typically, in case of a torch, you light up a torch, right, on a wall. You're near to the wall, the radius of the light will be small. Go away from the wall, the radius of the light will expand. Similarly, the coverage of these satellites expand. So, the height of the satellite and the number of satellites, both which are weakness of the system, they are being leveraged to give a coverage to the whole world in a manner that 99% of the surface of the world can be covered using satellites, whereas in terrestrial you can't do so, because there are various areas in the geography like ocean, etc., where terrestrial network cannot be deployed in a commercial viable manner, right? Which is why, friends, because of this challenge, that number of satellites are less, the coverage is pretty large as far as footprint is concerned, which is why, friends, we need satellite to operate in higher frequency band, because the satellite needs large blocks of spectrum. In the low frequency band, the satellites typically won't get that much amount of spectrum. Why satellite need large amount of spectrum? Because the number of satellites are less and the footprint is large, and if you have a low amount of spectrum, low quantum of spectrum, then the people who in this area will not be able to get good amount of speed, because the same block of spectrum will be used by the full populations residing over here. So, you need satellite to operate in high frequency band, where the quantum of spectrum that you can find is pretty large. Now, let's say you are operating in a frequency band which is 28 gigahertz to 30 gigahertz, and you have how much spectrum? You have got 2 gigahertz of spectrum. Now, you might already know that there is not one single satellite operator. There are multiple of them. Now you can't give 2 gigahertz to each of them because you don't have that much amount of spectrum. So you are forced to make all these operators share this block of spectrum. You cannot do exclusive assignment to each of them, right? It's very clear. But somebody may say that why not? You give exclusive assignment to each of them. Let's say if you have 2 gigahertz here and there are 5 operators, you give 400 megahertz to each of them. What problem it will have? The problem that we'll have, we'll talk about in the later part of this animation. Let the animation show up. So what will happen? Let's say, assume that a geo operator gets 400 megahertz, a MEO operator 1 gets 400 megahertz, like that everybody gets 400 megahertz. Then what happens, friends? Because the block of spectrum of 2 gigahertz is not fully utilized, even by all these operators. Why it can't be fully utilized by all these operators? Because the number of satellites are pretty less. So you can't leverage the full block of spectrum to the fullest capacity. So better to give each and every operator the full 2 gigahertz than slicing it into 400 megahertz each, because most of the spectrum will get wasted. And if the capacity is limited to only 400 megahertz, which is 1/5 of the total block of spectrum, then the user will get a very, very low speed. Versus if you give the full 2 gigahertz, then it is a big pipe being shared by multiple satellite operator, and the throughput per user can be pretty high. Which is why, friends, satellite spectrum is always shared spectrum, and that's why satellite spectrum should not be auctioned. There are multiple videos which I have made on this topic. Now, friends, let's talk about the another aspect, the satellite frequency band. What are these bands? Now, there are different type of bands, L band, S band. So let's talk about these bands. So you have these bands right in front of your screen. Now, every band has got a feature and a capability, right? There are certain positive and there are certain negative, which you can clearly see is popping out in your screen. Now, this is quite fast. And since I am going to shrink this video to 10 minutes, what I plan to do, I am going to give you a summary. So the summary is very simple here. You see that this is a summary right in front of your screen. So you have got L band, S band, C band, KU band and KA band, and this is the summary. The frequency, the rain fade, which has the highest rain fade, which is the KA band, interference, bandwidth, dish size, and the use case. So every frequency band has got a role to play, that you can't just disregard and saying that this frequency band is useless, because every frequency band from the point of view of physics will have to have a role to play in order to serve the consumer. Now, let's talk about why broadband need high frequencies. You can't deploy broadband in low frequency spectrum. Let's look at the reason why. First, in high frequency, you have got larger block of spectrum. And there is another reason, and this is the most important reason. In high frequency, the wavelength is very, very low. In low frequency, the wavelength is high. You know that C is equal to F lambda, right? C is the velocity of light, F is the frequency, and the lambda is the wavelength. Lambda minus multiplied frequency is velocity of light. Now what happens is that because the frequency is high, what you can do, you can have antenna design. Because the satellite real estate is pretty constrained. You need to have antennas which are small. Otherwise, if the antennas are big, the satellite becomes very difficult to manage. With a smaller antenna, with large number of antenna deployed in that satellite, you have the capability to create beams which are pretty sharp. Whereas if you are operating in low frequency band, because the antenna real estate is limited, the beam becomes pretty broad. Now, why do you need this smaller size and smaller sharp beams? Because, as I told you, the quantum of spectrum is limited. Now, if you are going to have the sharp beams, what you can do, in a single footprint that you have, you can create this smaller chunks of spectrum coverage areas, which you call frequency reuse. You can create sharp beams of smaller footprint, and therefore, what you can't do by deploying multiple satellites, you can do it by beam splitting, right? This is called beam shaping and beam splitting. So in this way, you can enhance the capacity of the satellite, just like what we do by deploying more number of base stations, right? Simple as that. Now, some satellites, right, are using lower frequency. Why? Let's talk about that. This is also important. You need to have some satellites operate at low frequency. Now, this all depends upon the form factor that you're using. Sometimes you have to have handheld mobile phones or terminals which will talk directly to satellites. Now, these mobile phones need to operate in low frequency band. The reason is that they can't track the satellite in high frequency band. That's the problem, right? So you see that they need to track the satellite because these satellites are moving at very, very high speed. Because of that, some of the satellites need to operate in low frequency band compared to broadband satellites which are fixed, and therefore they can operate in high frequency band because the dish is fixed and they can track the satellite electronically, whereas the people are moving and therefore they can't track the satellite electronically. And also some places you need to use the commercial frequency band to leverage the same mobile which you are using for your terrestrial coverage, and which is why the satellites have to work in the same frequency band which the terrestrial operators are using. Friends, that's all friends in this video. Just to summarize, we have learned these are the key takeaways. Satellite spectrum strategy differed from terrestrial, we understood. Satellite require large contiguous block of spectrum. Broadband satellites typically use higher frequency band. High frequency enables narrow beams for frequency reuse. Low frequency bands such as LNS, mobile and handheld satellite services. Modern system beginning to integrate satellite communication with terrestrial frequency bands. Thank you friends for your time. I'll come back with the next module soon.